To keep the radio communication secure during the World War II, the Nazi forces used the Enigma machine. The Germans thought that Enigma Cipher is unbreakable, but the cryptographers had already broken the cipher. Let's see how. First we will know about the components of the Enigma machine, and then we will get into its decryption process. The plug board consists of a panel of 26 double-sided socket mounted on the front of the machine. The plug board swaps the input of machine with some another letter. In the picture of plug board, the letter S is connected to the letter O, so whenever S is pressed on the keyboard it travels as O. Next we have rotors or scramblers. Out of 5, 3 rotors can be used in any order for the right, middle and left positions. Each rotor has an inner and an outer ring of contacts connected to each other, and each rotor is connected to the other rotor via this contacts. Furthermore, as each letter is pressed on the keyboard, the rotor rotates one position, and each rotor has a notch which when reached causes the next rotor to its left step forward. This whole process can be understood by this example, that how letter T turns into G. The machine itself doesn't transmit the message, so the operator had to write it down, and then the radio operator would transmit the message via Morse code on an open frequency. Now the second operator on the receiving end would set his machine as same as the machine used by his counterpart with the help of daily settings sheet and decode it. The Enigma is a very complex device with 150 million possible combination, but it was very critical for the Allies that the cryptographers break the code as quickly as possible to stop Nazis. However, there was a flaw in the design of Enigma, that whenever a key is pressed it never enciphers into itself. Using this, the Allies broke the code. They found out from the intercepted messages that some words has rhythm in which they appear. Germans used to send weather reports in a predefined format which had the word Wetterbericht, weather report in English. The Allies called this type of words as cribs. Now to locate where they appear in the message, the design flaw was used as shown. It is a wrong combination, as S in the crib and S in the cipher text coincides. So we will slide the crib a step. But here also the same situation arises. Now we will slide the message on the cipher text until no same letter appear in the crib and cipher text, and we get this orientation. So we have found out where the Wetterbericht is in the cipher text. Now a graph called menu will be formed as shown for the word Wetterbericht, but this is a very large menu to analyze. So let us take a smaller menu to understand it properly. Once the menu is formed, we will look for loops in it, that is VSAX. Then 4 plug board partners are assumed, that is S connected to Greek letter alpha, A connected to Greek letter beta, X connected to Greek letter gamma, V connected to Greek letter delta. This procedure used the symmetric behavior of Enigma and relationship between 2 plug board partners, that is, if S is connected to Greek letter alpha, then Greek letter alpha is connected to S. We have supposed S is the plug board partner of Greek letter alpha. So when S is pressed, Greek letter alpha will enter the rotor system and would come out as Greek letter beta. Now we have assumed that plug board partner of Greek letter beta is A, so A will light up in the lamp board. The same procedure will be followed for each member of the loop. Then suppose that hypothesis is Greek letter alpha equals G. Now the input in form of the electrical current is given to the loop, and if we get output as G, then only it was believed that plug board partner of S is G. They used to repeat the same procedure on the different menus of different messages, which will eventually give them Enigma setting for that day. However, this is not the actual internal wiring of the bomb machine, but the logic used was the same. As we know, each pixel in a colored picture can be represented using RGB, red, green, blue value. The range of RGB values is 0 to 255. That denotes the red, green and blue intensity of a particular picture. These RGB values are taken one by one and changed into another by Enigma encryption, and hence it is not possible to track the original RGB value. In order to retrieve the original image without the initial settings, one has to use the same logic used in the bomb, but this time the number of possible inputs has been increased to 256 from 26, which is way more complicated. So one has to have correct key to reveal the image.